Hello, welcome back. Today we are looking at naming ions notes. Hope you had a great break. I hope you had a little rest. And here we are getting back into it. We've talked about some of this stuff already, so it's going to be a little bit of a review here, but we'll add a few pieces in here to help us out. So first off, one of the ideas we can talk about is a monatomic ion, just to define some terms. That sounds like a big word, but really when we break it down, it's not so bad. Mono, that prefix again means one. Atomic, well, atom. So one atom. So we're talking about taking an atom from the periodic table and gaining or losing electrons. Remember, a cation is a positive ion, it's lost electrons. An anion is a negative anion. It has gained electrons. And so that's what we're thinking about on those. Then we have this idea of hydrogen. Hydrogen can be a plus or a minus. We're going to look at it later. It's most commonly a plus. However, sometimes it can be a 1- ion. And so we're thinking about that. Remember, because it can be +1 and get to 0, or it can be -1 and gain 1 and have 2 electrons. It would be a full shell. Most commonly the H1 plus for hydrogen. That's why it's with group 1, the alkali metals, because it tends to form that +1. Now here's the thing about transition metals specifically. Remember that D block. One of the key characteristics is that a lot of them have multiple options for what ion they form. So like iron could be a 2+ or a 3+. Remember, iron is Fe. And so what we're going to do to indicate that is that it could either be, we're going to use a Roman numeral for iron 2, that means iron 2+. Iron 3, that means iron Roman numeral 3, that means iron 3+. The Roman numeral tells you what charge it's going to be. And the reason, again, they can have multiple charges is because of those D electrons. And so you remember, so like iron is going to have 4s2 and then 3d6. And so it can lose the 2 valence from the 4s2, and that's how you get a 2+. It can also lose the 2 valence and then the extra one going down to a d5, because then you would have one less. With d6, remember, you'd put 1 into each of the 5 orbitals. The 6th one would have to pair up, and so that 6th one could be lost a little bit easier. So that's how it forms a 3+. But again, the D gets kind of funky there. Sometimes the D even will steal one from the S. Anyway, there's some exceptions to those, but that's why these multiple ions occurs. Look at vanadium, has like 4 different ions. So we got to make sure that we write the Roman numeral. Anytime you're in the D block, it's a good idea to write a Roman numeral just to be really clear about what charge ion you're talking about. And just a little review of Roman numerals. 1, 2, and 3 are pretty straightforward. V means 5, and so 4 is actually, you put the I before the V. That means subtract 1 from 5, 1 less than 5. So then 5, 6 would be 5 plus an extra 1 at the end. 7 would be plus those. We're not going to get more than 7. But there we go. A little quick review on that. Those were monoatomic. The other idea is polyatomic ions, and we looked at these a little bit as we did some covalent Lewis structures. Again, this is a covalently bonded group of ions that has gained or lost electrons. The whole group has gained or lost electrons. So here we have NH4 1+, that's 4 hydrogens with 1 oxygen, and the whole group has lost 1 electron, so that's why it's a +1. Nitrate, NO3 1-, the whole group again has gained 1 electron, and we drew out those structures a little bit in the last chapter, drawing those out, how we have single and double, sometimes triple bonds in here. Sulfate is SO4 2-, and phosphate is PO4 3-. Now we're going to have them listed on the back of a periodic table. I will post a periodic table that you may use that has these listed on the back here. So I will make sure that gets posted so you can see that and go from there. So that's kind of the big idea on ions. We've talked about a lot of these things, just a little review, brush up. You're going to be doing a couple of review things early this week as we get back from break, just to get our brains back on what we're talking about with ions and ionic bonds. Then we're going to work on naming them. So here we go. What type of elements tend to form cations? Which type tend to form anions? And how are polyatomics different from monoatomics? You got it. Yep. Cations from metals, anions from nonmetals. Polyatomic means you have multiple atoms that are covalently bonded in a group, and then that group is an ion in an ionic crystal. Monatomic is just going to be the single atom in an ionic crystal. All right. Very good. Have a great day.